Example 7.9. Light of wavelength 500 nanometer passes through a slit of 0.2 millimeter wide. The diffraction pattern is formed on the screen 60 centimeter away. Determine the angular spread of central maximum. The distance between the central maximum and second minimum. What are the things given? Yes, the wavelength is given. The wavelength is given as 500 nanometer. So this is 500 into 10 raised to minus 9 meter. And the distance between the slits is given. Here that is A. Okay, that is 0.2 millimeter. So it is 0.2 into 10 raised to minus 3 meter. And the distance between the source and the screen is given, that is capital D, that is 60 centimeter. So it is 60 into 10 raised to minus 2 meter. Now what is the first part is, we have to find out the angular spread of central maximum. So to find out the angular spread of central maximum, we have to write the equation for diffraction minimum. Okay, so the equation for diffraction minimum. So what is the equation for diffraction minimum? That is A sin theta is equal to n lambda. Okay. Now you have to find out the angular spread of central maximum. Okay. So the central maximum here spreads up to first minimum. Now here this is your central maximum. Okay. Now this is your first minimum. So this area is what it is spreading area. That is from here to here it is central maximum. Here to here it is what? Central maximum. Here so we can take it n is equal to what? 1. So I can write A sin theta is equal to lambda. So we have to find out the angular spread. Angular spread is nothing but the theta. So sin theta is equal to lambda by A. So what is theta? Theta is equal to sin inverse lambda by A. So you know the value for lambda and A. So lambda is 500 into 10 raised to minus 9. A value is 0.2 into 10 raised to minus 3. Okay. So if you divide these values, you will be getting it as 2.5 into 10 raised to minus 3. So here we have to find out the value of theta in radian. So in order to find out the value of theta in radian, we will be getting it as 0.0025 radian. Now we will go for the B part. We have to find out the distance between the central maximum and second minimum. Okay. Now this is your central maximum and this is your first minimum and this is your second minimum. So we have to find out the distance between this and this. Now here the first minimum, central maximum spreads up to first minimum. The first minimum spreads up to what? Second minimum. So let us go for finding the first minimum. Okay. So to find out the first minimum. Okay. For the first minimum, the value of n is equal to 1. We know A sin theta is equal to n lambda. So, A sin theta is equal to lambda. Okay. Here we are going to take theta is small. Theta is small. So, when we take theta is very small, we can approximate sin theta as tan theta. Okay. So I can write tan theta is equal to y1 by d. This is already we have found out. Okay. So tan theta is equal to what? Y1 by t. So now I am going to equate it for sin theta. So A, here sin theta is tan theta is y1 by d. So I can write A tan theta is equal to lambda. So A y1 by d is equal to lambda. Okay. So we have to find out y1. y1 is equal to lambda d by A. Okay. So here the tan theta value we have already calculated in the theory. Okay. So now we'll go for y1. y1 is equal to lambda value is 500 into 10 raised to minus 9 into 60 into 10 raised to minus 2 divided by A value is 0.2 into 10 raised to minus 3. So here if you multiply these things, here it is cancelling, and if you take it, you will be getting it as 1.5 into 10 raised to minus 3. So that is 1.5 millimeter. Now we'll go for finding the second maximum. To find the value of second minimum, sorry. So what is the value of n? N is equal to 2. So A sin theta is equal to 2 lambda. Okay. So we can apply as like the previous one. So we'll write A. Okay. For tan theta, here it is tan theta. So for that is the distance is y2. We'll take it as what? y2. So we can write it as y2 by d is equal to 2 lambda. So what is y2? y2 is equal to 2 lambda d by A. So if you substitute 500 into 10 raised to minus 9 into, you will be getting a 2 here. I left the 2. So here it is 2 into 60 into 10 raised to minus 2 divided by 0.2 into 10 raised to minus 3. So here this is twice that of the previous one. So you will be getting it as what? 3 into 10 raised to minus 3 meter. So that is 3 millimeter. Now we have to find out the distance between these two. So what is the distance between the central maximum and second minimum? So the distance between central maximum and central minimum and second minimum. So that is y2 minus y1. So what is your y2 value? 3 millimeter minus 1.5 millimeter. So what you are getting here, it is 1.5 millimeter. So this is the distance between the central minimum and the second minimum.